Hello everyone, just a few notes on your formal report for the acetaminophen lab. So again, remember you've got those instructions on the D2L page, what should be in the formal report, what the sections are, all that kind of stuff. Abstract, again, purpose, procedure, major results and conclusions, being specific about your numerical results, what are your key findings for each of your three formulations. Then experimental, right, that overview of your procedure. A lot of people in the first experiment maybe did it more in a procedure style, like you do in the lab manual. That's not really the style we're aiming for. Remember, it's not like instructions, it's past tense, passive voice, and again, you'll cite our lab manual, or the lab handout. So it doesn't need to have, every sentence of exactly how you turn on and calibrate the spectrophotometer or something like that. It should just be very specific about exactly what experiments you did. You added this amount of this chemical with this concentration and, measured the absorbance at this specific wavelength or took an absorbance spectrum. Very brief and concise is sort of the goal, just sort of stating all the experiments that you did, nothing else. Okay, then the results, again, this is the key part of your report. A lot of people reading a report or a scientific paper wouldn't even really read the experimental because that's more for people who are interested in replicating the experiment. If you're just a reader not interested in performing it again, you might go right from the abstract to the results section. In results, in this case, right, your key results are related to quantifying your standard curve, right, so your Farinanin. So in this results section, right, you're going to need to have information about, again, for the reader who's never done this experiment, start from like step one of, okay, you've got your experimental up here, a couple of nice paragraphs. Your results, again, are going to be, in this case, right, you've got to talk through every experiment that you performed, right? So your first experiment was sort of your standard curve, the Farinanin, acetaminophen standard curve, right, where you are then able to get that nice figure, right? So you're going to have that figure that's the standard curve for Farinanin that we made in our last week of lab, which shows, absorbance versus concentration of Farinanin to quantify exactly what absorbance corresponds to which concentration of Farinanin. Just like last week, you should, report slope, intercept, correct units. In this case, again, we're also reporting the value of the molar absorptivity epsilon. Oops, that's the wrong epsilon. Air epsilon. So epsilon here, again, if you go into equation editor, you can grab all the correct equations there. So again, insert and grab the correct value there. You can go in and find all the symbols there, the little epsilon and things like that, right? You're going to report epsilon again with correct units. From that previous thing, remember we have a literature citation for that as well. So you'll want to cite literature for accepted value for epsilon. We talked about that. Again, remember that epsilon is the molar absorptivity. You're going to be reporting the molar absorptivity of Farinanin at whatever it is, 500 and some nanometers is blank, compared to in literature, it was whatever it was, 11,100. So again, that's, going through all of that from very much the same as the last one, right? This will be figure 1 with, good descriptive title. That's what that is going to look like. Again, make sure you've got all that text walking the reader through it. Then you're going to get into your results from the next weeks, right? So you're going to need to talk through your results for the 3 different formulations. So you're going to have those 3 figures that quantify how much acetaminophen was released versus time. That'll be figures sort of 2 through 4. And then you'll want that sort of table that summarizes all that data. So talk through, here are the results, and then using the data from those figures and using figure 1, 2, you're also then going to have your sort of sample calculation how you got from absorbance to the concentration, or to the, milligrams of acetaminophen. Right, we took a long time to walk through that calculation. There are a lot of steps there, but just sort of walk through that, explain what went on in that sample calculation. That's sort of the main sample calculation here, the biggest one. In this case, you'll want to do this calculation here as well. Right, for this you'll need to say like how you calculated the concentration of ferritin. So right, using the concentration of the acetaminophen, again, just that sample calculation that we walked through on Monday. And then again, your table, you'll want to say, okay, how did you get the data in that table? I would recommend putting in sort of three numbers there. If you put in both you'll want to put in sort of the slope that we talked about, getting the slope of the linear region, the final average acetaminophen that we talked about in lab, and I would also put the amount of acetaminophen that you got out in the first 2 minutes. So if you look at the data, again, I'm going to go pull up the data up here. So here's the average class data. Again, you're free to use this however you want in your report. I would definitely, in terms of the conclusions that you draw from your data, make sure that you also reference the overall class data as well, since you don't want to sort of draw conclusions that are out ahead of what your data actually says. Quantifying that rate of release and the total amount of acetaminophen, right? We got average values for each of these 3 formulations. I don't know, the overall averages are not bad, right? Remember, each of these tablets in theory contain 500 milligrams, right? I don't know, if you average all these out, a little bit over 500 we got out for the caplet, a little bit over 500, maybe 550 for the tablet, and more like 600 for the gel cap. Not, the best agreement, but pretty close. There again are a lot of potential sources of error here, but pretty decent agreement with what's on the package there. And then for the rate of release, again, you'll want to sort of draw, probably pretty measured conclusions about what we learned from the rate of release. Certainly we have some information about roughly how long it takes, right? In this case, it looks like, for all of them, they look to be sort of fully released in 30 minutes, certainly, and a lot of them are fully released quite a bit faster than that as well under those stomach acid conditions. To me, one conclusion that pops out right away is this tablet has a ton that actually is released within those first 2 minutes, whereas the other two have actually very little released in 2 minutes. So that's why it's not a good idea maybe to add in the immediate released in 2 minutes. That might be a nice column in your chart so you can sort of quantify, hey, we actually got out, a significant fraction of the tablet within that first 2 minutes. The slope of this tablet line, if we actually draw a line on there, is going to be lower, but that's just because so much of it actually released out in the first 2 minutes. So, if you're thinking about which one released fastest, the tablet released a ton really, really quickly compared to these other two that release a little bit slower when you've got the caplet and the gel cap. You can compare that to your hypothesis going into the experiment that you wrote down in your pre-lab. I also have this version of the class data with error bars, so you can certainly use that as well. That I put in here again. It looks like a little bit messy. You can also sort of go in here and click lines on and off to just sort of look at each one on its own. To me, the key takeaway there is just not to be too aggressive in the conclusions that you draw, right? These error bars are quite wide. Again, if I take the tablet off, caplet and gel cap, there's some differences between those two on average, but not huge differences. A lot of them are pretty near within the error bars. And so, yeah, just, sort of qualify your conclusions in that way. There's still pretty big error bars. We only have 4 experiments that we're averaging together here. So again, still very large error bars. The tablet, again, on the other hand, though, is sort of a different line compared to either of the other two. I mean, you can see that there's this initial release of the tablet is way outside of the error bars. That's not, that does seem like a very significant result, that tablet is releasing faster than either of the other two significantly. Those error bars don't overlap really at all in the first 2, 4, 5 minutes. So that's a significant finding. Yeah, again, your discussion will talk about sources of error. Again, you can read through the lab manual again. I'm happy to look it over. Definitely get to work. Here's Matthew eating some watermelon. But yeah, I'm happy to read that over and look through all of that. If you've got questions, let's see, where is that actually? Okay, so yeah, looking at the acetaminophen data here, again, you've got your objective. For your idea here, we've got, again, your hypothesis that might be nice to refer back to. We've got a linear region where you're going to get sort of a slope of the linear region, as we talked about. Again, talk about the content in each formulation. What did you get for, sort of percent error for each? Compare it to the class averages that we've got. Again, if we look at our hypothesis, how does that compare back to your hypothesis? And then a little bit about the actual conditions of the reaction. That'll think about some of those sources of error, which again are potentially significant in this sort of procedure.